right, now least common multiples. If you remember from a previous video, multiples are where you multiply the number and you keep getting bigger and bigger products. So for the multiples of 6, you would take 6, multiply by 2 to get 12, multiply by 3 to get 18, by 4 to get 24, by 5 to get 30, and so on. And remember that there are an infinite number of multiples because you can just keep on multiplying bigger and bigger numbers. If a problem wanted you to find the least common multiple between two or more numbers, you would list the multiples of both those numbers. I would say probably at least to the 5th multiple, and then pause because you don't want to go on forever, and figure out the smallest common multiple that they have. Okay, so in this case, they listed the multiples of 6 and 8, and they bolded the multiples they have in common here. So they have 24, 48. If they were to continue listing the multiples, they would find even more common multiples. But again, we want to stop at a reasonable place because we just need to find the least common multiple, the smallest number they have in common, and that is 24. There is actually a second method for finding least common multiple. And in this method, you're actually working downwards with your numbers. You're not listing them, the multiples, sideways, and you're using prime factorization. So in this problem, we're trying to find the least common multiple between 24 and 90, the LCM of 24 and 90. So if you notice, what they did here was they listed 24 and 90 next to each other with a comma in between, and then they're taking out prime factors, our favorite concept, prime factors. They first chose 24 divided by 2, which will get you 12. So then they changed the 24 into 12 when they dropped it down here. 90 divided by 2 is 45. So down here, 90 became 45 when they took out the prime factor of 2. Next, they took out 2 again, another prime factor of 2. 12 divided by 2 is 6. 45 divided by 2, can't do that, so they kept it as 45. So very important. If it's not divisible by that prime factor, then you just keep it, okay? And then next they try to take out a 2 again. 6 divided by 2 is 3. 45 again can't be divisible by 2, so they kept it as 45 again. Next prime factor, they took out 3. 3 divided by 3 is 1. 45 divided by 3 is 15. So 3 and 45 become 1 and 15. Took out another 3. 1 can't be divisible by 3, so they kept the 1. 15 divided by 3 is 5. And lastly, they took out the prime factor of 5. So at the end, they know they're done when they just have 1s left over. And then the least common multiple is literally all these factors that they took out, and they multiply them together to get 360. So that's the second method of finding the least common multiple. So we're going to actually go over an example next, and you'll be able to see both those methods in action so that you can decide which method you like better. Go ahead and pause the video and try this problem on your own. Find the least common multiple of 40 and 150. Use whichever method you want to try out. All right, I'm going to first use my traditional method, which is listing the multiples. I'm going to give plenty of room because I have 40 and 150. So I'm going to list 40, 80. Remember, these are multiples, so they're going to become bigger and bigger and bigger. 200, 240, 280, 320, 360, 400, 440, 480, what is that? 520 560 and 600, and that's all I can fit there. 150 is 150, 300, 450, 600, 750. I think I can stop. Don't we have enough already? 900. Let's see, do we have 150 in common? No. Do we have 300 in common? No. Do we have 450 in common? No. 600. Wow, that was a lot of multiples, right? But 600 is our least common multiple. Think to yourself the pros and cons of that method. Then we're actually going to try the second method, which was the prime factorization method. So we're going to list the numbers 40 and 150. We're going to take out the prime numbers. Hopefully I have enough room here. We're going to first take out, let's say 5. 5 can go into both of them. 5 times 8 is 40. 5 times 30 is 150. Let's take out 2. 2 times 4 is 8. 2 times 15 is 30. Let's see, 2. 2 times 2 is 4. 2 doesn't go into 15, so we're going to keep that the same. 2 goes into 2 one time. 2 doesn't go into 15. We'll keep that the same. 3 doesn't go into 1. Keep that the same. 3 goes into 15 5 times. And lastly, 5. Keep the 1 the same because it doesn't go into it. 5 goes into 5 one time. We're done when we know there's just the 1s left over. And we need to multiply these prime numbers together. So 5 times 2 times 2 times 2, 3 2's, times 3 times 5. That'll give us the answer. Let me put that in my calculator. So again, 5 times 2 times 2 times 2 times 3 times 5. And that gives me 600. So both those methods work to get us the least common multiple. One is heavier on multiplication, the traditional method of listing out the multiples, and the other is heavier on division and prime factors. They both take up a lot of room. One is both more horizontal and one is more vertical, up and down. So when you're working on your problems today, decide which method you like better. Maybe you like both of them. But yeah, have fun.